In this video, we want to show that the derivative given here is equal to this expression on the right side. And this is more or less just a practice on derivatives. This is one problem we had done in a previous video, showing that the integral of cosine squared of x over cotangent cube of x was equal to this expression here. So this is just a check on that derivative that we got, or that integral that we got. So we're going to pause the video here, see if you can work this out. I'll be right back. So we start with the left side then. So this is equal to, it's like proving a regular identity, trig identity. We want to get this, that's the final answer. So let's compute the derivative of this expression here, term by term. So let's do this first. Natural log, the derivative of that is minus, and then the cosine goes in the denominator, cosine of x. And then we take the derivative of the cosine, that's minus sine of x, so we have a double negative there. And then we have a plus over here. We have the square of cosine, so this will be using your general part root 2 in front here, and that 2 cancels out. So this will be cosine of x. And then it's the derivative, using the chain rule, it's the derivative of cosine is minus sine of x. And of course the derivative of constant is 0. So then this is equal to, double negative there makes that a sine of x over cosine. And then getting the same denominator here, we'll multiply numerator here and denominator of this is just be over 1, say. So we multiply by cosine, and then got a negative there, so let's bring that over. Minus, and this will be cosine squared of x, sine of x. And that's over cosine. So multiplied cosine in this denominator and top to get the common denominator. And then what I'm going to do is I'm going to rewrite cosine squared is the same thing as 1 minus sine squared of x. So this will equal to, at the same denominator now, cosine of x, and then we have sine of x here, and then now we're multiplying this expression right here by sine of x. So it'll be sine of x there, and then a minus, so it'll be a minus sine of x, and then sine times minus sine squared. That could be sine cubed, and you get a minus here, so that's going to make that a plus sine cube of x. So sine x minus sine x, that cancels, goes to 0. I'm going to come over here on this side, put it over here, equals to, and then we have sine cube of x over cosine of x. Then I'm looking at my objective over here. This is what I want to come up with. So what I'm going to do next is I'm going to multiply the numerator and denominator by cosine squared. Of x. We get that. And then this equals to cosine squared of x. And then notice here I have sine cube of x, and these two right here give me a cosine cube. So I got sine cube of x over cosine cube of x. Well, that's tangent cube of x. And then finally, we want to come up with cotangent. Well, tangent and cotangent are reciprocals. So I got my cosine cube, or I should say cosine squared. And you can think of tangent cube of x over, think of that as 1 over cotangent, multiplied by cotangent cube. Well, Or just bring it down to the denominator and the tangent cube becomes cotangent cube of x. And we got the result we wanted. So the derivative is confirmed. Thanks for watching. We'll see you next time.